Hopefully this works. Turn off my phone. Yeah, that'll work. Okay. Today we are doing OOP, Object-Oriented Programming. There's sort of 1.5 lessons on this. There's today and Thursday, but Thursday is also a look at Typescript, which works really nicely with object-oriented programming, but it doesn't have to. It's just kind of adding extra functionality on top of JavaScript, but we'll talk about that on Thursday. This is mostly going to be a bit abstract and a bit kind of about the idea of object-oriented programming and some of the principles, and then so there's not really going to be any coding for during the slides. Then after the slides are done, we'll go and make a game, and games lend themselves really nicely to object-oriented programming, or the other way around. And so I think it's a nice exercise to do, to kind of make a game using classes and objects. And so we're going to do that. So if you want to think about some fun stuff we can add to a game that might be something like, something like Space Invaders or Asteroids or Snake or something along those lines, then at the end we'll go ahead and see what we can get done. So it is unsurprisingly a paradigm organized around objects. It is, and by objects we don't mean stores of key value pairs. So objects in JavaScript are, they're curly brackets, they've got keys, and those keys have values stored against them. That's not quite the same thing that we're referring to now. Objects in OOP are kind of referring to real world objects. So a laptop would be an instance of the class computer, and a particular laptop has its own properties, and that would be an object. The word object doesn't really, kind of weirdly, doesn't really come up that much when you're talking about object-oriented programming, and we're still going to refer to key value stores as objects. But classes and instances, these are the two things that we're actually going to be talking about. So it's intended to follow real-world behavior. There are lots of kind of classic examples about examples of how people describe object-oriented programming using cars and animals and things, because it can kind of be mapped to the real world. You might say it improves organization. Compared to the code you've been writing so far, I think it certainly will improve organization, but that's not necessarily to say that object-oriented programming always improves organization. It can easily turn into a bit of a mess, but hopefully it might give you some ideas about how you can clean up your code or your projects generally. So we're going to talk about 4 principles. There are more, but we're going to talk about these 4, and really depending on what you read, there's anything from kind of 4 to 7 main principles of object-oriented programming. But we're going to talk about these 4. Encapsulation, abstraction, inheritance, and polymorphism. Just for fun, can anyone guess at a sort of completely random, off the top of your head, description of what these might actually be? What might encapsulation be, abstraction, inheritance, or polymorphism? I want an answer for each of them, so if you just say anything, we'll get it over and done with quicker.
Is inheritance like taking behavior from some other place and applying it?
Yeah, exactly. Yeah. So you have some behavior stored in one place, and another object will kind of inherit that behavior from it. Yeah, perfect.
Nice. Someone else can jump in on the rest.
Yeah.
That was a smart move, Izzy. That was a very smart move.
Just wildly out of guess encapsulation. Taking other code and making it smaller, and like I don't know. No, that's not it.
I mean, you're not too far off. Yeah, it's sort of something like that.
Right.
Yeah, like kind of wrapping it in its own area. Yeah, abstraction. I mean, there's no these. I don't like these words. They don't really mean anything, and it would be nice if there were slightly more descriptive words that do just that do describe what it is a bit more directly. But these are really kind of industry-wide terms, so it's kind of. I always find it interesting to hear what people's first impressions are for this. What about abstraction?
I feel like that's just code that's in and of itself, it's like outside of everything else, but it's kind of standalone.
Yeah, it's about like what you want to take away from the responsibility of some other object, and you want to make it by itself. And yeah, exactly. And lastly, polymorphism.
Yeah, see, I don't use that word in everyday life.
Yeah.
Many forms.
Yeah, many forms. That's what it means literally. So it's basically referring to how objects can actually be multiple different things at the same time. But good, yeah. So they sort of make a little bit of sense, but really you don't have to remember these terms so much. You might do for kind of interviews and things, but it's only about the general rules and reasons why these happen. That's the more important thing. Okay, so encapsulation basically means objects store their own data. So there's data and variables inside objects, and other objects can't necessarily get access to those variables. An object exposes their variables or functions or whatever using methods or functions. These are known as getters or setters. A getter is a function that just gets the current value of a variable, and a setter is a function that sets the value of a variable to a new value. So encapsulation is about objects storing data within themselves. So this is pseudocode. This is supposed to be sort of read, kind of read like English or whatever. So don't worry about the syntax or any of this. Really, it's kind of nonsense. But we're going to define a class called a person. We're going to make. We're playing God right now, or sort of Westworld or something, and we are creating the kind of basis for a person. We're going to decide that a person has particular attributes. They have a name, an age, and a location. We are kind of allowing people to know our name, we are creating a getter that returns attributes.name. So if we have this is like an object, we've got whatever value we've currently stored in name, we are going to allow another person to access my name, to access the name of a particular person. Here we're going to allow, for some reason, another person to set the age of this person. So we're exposing a setter called age. It takes a new age and then it sets attributes.age to be that new age. So each person, each instance of this class, so by using this class person we can create 2 or 2 billion or any number of instances of this class. Each one of those instances, they're going to have their own data stored in name, age and location. Anything else can access the name, anything else can set the age, but actually we can't access the location, and we can't even access the name, and we can't the age, sorry, and we can't set the name. So we are encapsulating these values and exposing these actions. So here we have another action. If we don't actually want someone to be able to just arbitrarily set someone's age, if they were 20 before and they suddenly set it to 30, that's not going to happen. So we are now only going to expose, okay, imagine we've also got the attributes here. We're now only going to expose a function. It's neither a getter nor a setter, it is just a function or a method. Those terms are kind of interchangeable, called happy birthday. And when someone else says happy birthday, I mean, on your actual birthday you might in fact age like 10 times if lots of people say happy birthday to you, but let's forget about that. When someone else calls the function happy birthday on a particular person, they're actually just going to increase the age by 1. So now we have kind of kept the functionality of the age and setting the age a little bit separate, and really the only thing that we can do with the age is increase it by 1 by calling happy birthday. So now we have introduced private and public. Actually, there's kind of 3 things. There's private, public, and this. These 3 things have just been introduced. Now, think and eat, these are methods or functions on a person. Person.eat, it sets attributes.hungry to false, they've eaten, and that's public. Like, someone else can feed me and kind of tell me to eat or encourage me to eat or something, and I'm now no longer hungry. But think, no one else can tell me to think, sort of. So the think function is private. Only I can actually think. So here we're just going to say, if I'm hungry, I'm going to, I don't know, return this string, otherwise I return this string. And now we have a public function called live, and I don't know, someone else, a parent of this person can call the function live, and they call other functions on themselves. So this is a keyword, it's a special term that I don't really think you've come across yet, but it's a keyword that refers to the current instance of person. So if we have 10 different people there's actually going to be 10 different versions of this function, and inside it, this is going to refer to each one of those 10 different people. So inside this function, we can call this.think, then we can call this.eat, and then we can call this.think again. It calls hungry, and this can call a public function, this can call a private function, but another person cannot call a private function. So Sam is a new person. Sam.think, actually that's not allowed. That is a private function. So I'm saying another person can't call a private function, but here where we have created an instance of a class, and outside of this class, which is in here, we're outside of the class, we can't access that private function. So sam.think isn't allowed, sam.eat is allowed, and sam.live is also allowed because those are denoted as public functions. So that's it for encapsulation. It's about keeping things self-contained and deciding what can be accessed from outside of the object. Any questions on encapsulation? Oh, is that Dahe? Dahe, you've joined us. That's a no then. Okay.
Sorry. My microphone was on while I was talking.
Okay, no
I was
worries.
talking to myself. Sorry. When does this actually get created? Is that something that just happens by JavaScript itself, or like how does that work?
Ah, this, the keyword. Yeah, it's something that is created by JavaScript itself, and it's in fact kind of always there. You could have used it previously, depending on how your functions are called. This might actually be referring to the window or the document or a particular button or all sorts of things. This in JavaScript actually is really weird and confusing, but in object-oriented programming it's really useful. And also, just a note, we aren't really talking about JavaScript yet. And in other languages, it's not necessarily this. In Ruby, for example, it's self. So kind of myself, self.think is doing the exact same thing as in JavaScript, this.think. So it's not always this, just in JavaScript it is.
Nice one. Cheers.
No worries. Okay, abstraction. So programs can get really massive. This kind of is fairly related to encapsulation. But when you have tons and tons of objects interacting with each other, and just your code interacting with all of these objects, it can get really, really confusing. So exposed methods should be clear and high level. So by high level, that means so high and low level in sort of programming terms. High level means readable to humans, and low level means readable to computers. So the lowest level would be like machine code, and the highest level would kind of be something like JavaScript or Ruby that's designed specifically to be very readable and friendly. So you want the functions, the methods that you expose to other objects to be really high level, and like you want them to read really nicely, so that if you have a class called family, and inside a family that has a bunch of instances of person, on each of those instances of person you'll want to call a class called eat, but maybe you'd actually create several functions, several functions, one called eat breakfast, one called eat lunch, one called eat dinner, like really clear, and you don't have to dig into that other class to figure out what it's actually doing. You want things to be really nicely written and clear. So classes should be self-contained. It's kind of the same thing as encapsulation. It's about what we expose and how we expose it. So here we've got another class, we've got a menu, we've got two different buttons, we've got its kind of active state, and we've got a length of time that it should animate. So these, where in our person class we had a list of attributes, this is the same thing. So these are just kind of variables that we're storing inside a class, inside a menu instance, and they have default values, let's say. So it starts as false, and it's going to take 1,000 milliseconds to animate. So menu equals new menu, menu button 1.alpha equals 1, menu button 2.alpha equals 1, set timeout, menu active true, menu animation time. Like, this is going to be in a function called like handle click, or something like menu button.add event listener click. Then you do all of this. This is too much. Like, maybe the menu, actually your product owner decides that the buttons should be slightly less than 1, or it shouldn't only set active to true, it should set all these other properties and do all these other things after the animation time. So this is not clear enough at all. It's not abstract enough. So now we've got all of this pretty much the same, but actually they're now all private. So outside of the menu class, we can't access button 1, button 2, animation time, and active. All we can access is a method called activate. So inside the menu class is where it determines that, in fact, to activate a menu, which like reads like English, or kind of speaks like English, create a menu and then activate it. That's fairly obvious. Maybe you'd call this kind of display, or maybe you'd describe it slightly differently, but it's relatively clear that that's what we're doing. So now menu equals new menu, menu.activate. Nice. Ball equals new ball, ball.move, and it takes some coordinates to move to. So inside the ball class, we've got this public move method, which calls a private method that highlights the ball. It calls some other function somewhere else to move the ball. It calls emitter, it kind of emits some particles, and then it calls settle when it's finished. So I'm pretty sure I literally took this code from a project that someone had worked on, and they were kind of doing all of these things every time they wanted to move the ball, whereas just have one function on the ball called move that does all of these things, because maybe we decide we don't want the highlight, and then you'll have to do that. You have to remove that in 10 different places. So abstract stuff away so that outside of the class, it's really clear and understandable what's going on. Any questions on abstraction? That's a no. 37, we're making good progress. Okay. Inheritance. Because we have quite a lot of objects that are pretty similar, but they're not the same. So they're not identical. They're the same, but they're different. So inheritance allows us to use some of the same logic or code or properties in multiple different classes. So the terminology we use for this is child and parent, or it can be child and parent. You'll have a child class that inherits from a parent class. Like we could have our person class inherits from the, I don't know, mammal class, and then mammal inherits from, like, don't know, living thing. I mean, maybe that's a bit ridiculous. Let's look at the actual example in here. Okay, so we're back at the beginning with this person class. So got three attributes: name, age, and location. Blah blah blah. Get the name, set the age. We have a nurse, which is a person. So if we want to create a nurse, we're actually creating a person, and a nurse also has all of the attributes that a person has, because a nurse has a name and an age and a location. But we're also going to give them PPE and COVID trained. I think I wrote this when coronavirus was still fun. So we have a public function. If okay, COVID trained, we're going to set COVID trained to true or false depending on if the type is COVID. So it's a bit silly, but we're creating a new class that is a nurse, and that class inherits all of the stuff that a person has, and also has some other functionality. We've got another one, a celebrity. A celebrity has got a getter for the location, because obviously celebrities really do actually want everyone to know where they are. They call up a paparazzi, give them the location, and then they take some photos. So a nurse, we're adding some attributes. A celebrity actually doesn't get any additional attributes. We just have an extra function to expose the location. So Sam is a new nurse, is an instance of nurse. We can call sam.live because person.live is a function from 10 slides back. Same with happy birthday. Then we can call train because Sam is actually a nurse as well. We pass COVID, and now we can see that Sam is COVID trained. So we can extend our live function. We have the same public live function, and we've got some other one, this.care for people, because that's what nurses do. They care for people, but they also eat, sleep, and live and do all of the other things that humans do. But actually, parent.live, what we can do is call the equivalent live function that is on the person class. So I just want to check. Okay, no. So here we're exposing a live function, so we're actually overwriting the exposed live function that was in person, and now when we call live, we're actually calling this one. But if there's a bunch of stuff that we want to happen as well, we can call our own nurse functions, and we can call live on the parent class as well. So parent.live is not how it's done in JavaScript, but it's very, very similar, and just to sort of demonstrate the pseudocode and all of this stuff. So we're calling the live function on the parent class. Then we can go ahead and do our other stuff, but this is how we do it to access something on the parent class. So here, now we're going to create another class, COVID nurse, and we're saying COVID trained equals true. So it's just the same as a nurse, which is actually a person. So a COVID nurse is a nurse, and a nurse is a person, but we don't have to specify all of that. And a COVID nurse, by default, their COVID trained attribute is true. So inheritance is, I think encapsulation, abstraction, and inheritance, they're all like not super complicated to kind of understand the reasoning and why you would do it. Using them to their full kind of effectiveness can be pretty tricky, but these first three are fairly easy to at least understand why you might be doing it. Any questions on inheritance? Okay, last one. Polymorphism. It sounds complicated, but it actually isn't. It is actually relatively easy. I think I'm seeing there's only 2 slides on this because it's kind of sort of easy to understand. So it literally means many shapes. All classes which inherit from the same class can be used as that class. So all of our nurses can be used as persons. Now, because JavaScript is not strictly object-oriented and it's not strongly typed, it's not super appropriate in JavaScript, and it is more appropriate in other languages, and we're going to look at Typescript on Thursday, where it is appropriate. But if we think about this nurse, well, let's look at happy birthday person. Okay, person, no COVID nurse. Yeah. If we think about this example on a nurse that we've just created, live, we are kind of using it as a person. So in JavaScript, it doesn't really matter. We don't have to say that it is a nurse and it is a person and all of that. As long as there's a function there called live, then JavaScript's just going to let us do that. So here is where strongly typed languages differ to JavaScript or dynamically typed languages. So that's how you would write it in JavaScript, and this is fine. So birthday party person, happy birthday, like that kind of makes sense. And here we create a person and we pass the person in, but we just want to be really explicit that it is in fact, this person is definitely going to be an instance of the class person. So in this example, it's kind of overkill. We don't really need it. But down here, what if we were doing something a bit stupid and we tried to call birthday party with the number 5? In JavaScript, it's just going to sort of let us do that and kind of try to do that, and it's going to say happy birthday is not a function. But in strongly typed languages, it's not even going to run. It's going to tell you in the console, it's going to say, now you're trying to do something, or you would be trying to do something that just wouldn't work. So it kind of tells you even before you test it, which is why strongly typed languages are really, really good, and it's why Typescript exists. But here, it just wouldn't be allowed. Whereas this one, Vasile is new COVID nurse, birthday party Vasile, it is allowed, even though we are only specifying that it's a person, and we're not specifying person or nurse or COVID nurse. We might think that we need to do something like that, but actually, because COVID nurse and nurse both inherit from the person class, they all adhere to the kind of rules that a person has specified. So that's actually all polymorphism means. It just means when a class inherits from another class, it can be used interchangeably with that parent class. Okay, any questions on polymorphism? I think I'm going to probably stop the recording and start again because I sort of feel my computer getting slow, and I don't want to lose it, and I don't want it to be slow for the next hour or so. Any questions on object-oriented programming as a concept? Because now we're going to build a game using object-oriented principles. Okay, that sounds like a no. So here we've got an index file with a canvas. We've got some JavaScript that I'll explain in a minute, and this is the page that we've got. Now this element, this green one, is slightly different to elements that you've encountered before. If any of you used Flash back in the day, in the golden age of web games, Canvas was a sort of move towards creating something like Flash, and these days you kind of can do lots of stuff with the canvas element, but it is one element that's sort of like an interactive image. So we're going to be able to kind of create rectangles and circles. You can get images in there and text in there, and it's all just going to be one canvas element. It's not going to be creating this sort of nested DOM hierarchy with divs with style and text elements and all of that stuff. There's not going to be any of that. It's all just drawing pixels to what is basically an image. In fact, you can save image as, but because the background is actually just CSS, the background color is CSS, it's come up with just a big old empty image. So just to demonstrate, context dot fill style equals yellow. I'll explain this in a second, but it's not super important because it's not really fill rect 100, 100, 100, 100. So now if we call save image, we can see there's kind of nothing, it's all empty and blank, but this yellow square that we have just drawn to the canvas, it is now included. So that's what I mean by it's sort of an interactive image. So we're going to use this. I suppose we'll start off with kind of a yellow square like this. We'll move it around. We'll create several instances of our yellow square, and then we'll kind of evolve it into some kind of game where we can move something around. We could, I don't know, collect stuff. We'll see how far we get. So most of the stuff that's in here you don't really need to worry about, but I will just explain it anyway. We find the canvas element in the page, then we call a function on that canvas element called getContext, which gives us the context. It gives us a bunch of functions that allow us to draw onto the canvas. That's basically it. If you do anything with the canvas in the future, you will probably see it shortened to CTX. In fact, on here, even the official MDN stuff, CTX is shortened. Context is shortened to CTX. But I'm going to be explicit. So we have our context. We've got a couple of functions here. Currently, there's nothing in update, but in draw, first we clear it. So we clear the entire canvas. I'll show you why we do that in a second. And then we draw that yellow rectangle. We've got this function called main, which is the function that's going to run 60 times a second. So in games, you want the game to be updating and rendering at a sort of steady rate. So this function gets called very, very often. First, it calls the function update, then it calls the function draw, then it calls request animation frame, which you don't really need to worry about, but basically it's a little bit like sort of set timeout or something, but it's saying to the browser, okay, I want you to call this function on the next rendering cycle. So we call it once, and then we call it every single time at the end of this function, and so that means it's a loop. This is the main game loop. So 60 times every second it calls update, then it calls draw. It figures out the new positions of stuff, and then it calls draw to display them onto our page. Let's demonstrate what we want to do. X is 0, let Y is also 0. In update, we're going to increase X and increase Y, and then in draw, we just use those values to display the new position on our page. So now, 60 times a second, it is adding 1 to these values, and eventually it kind of appears down here and it's outside of the canvas. So let's have a look at what happens if we don't clear the canvas before we draw the new rectangle position. So by calling draw rect or fill rect, we're saying, hey, on the context on the canvas, fill in these pixels with the current fill style. And at no point does it say, okay, let's get rid of the old rectangle there. So in this draw function that happens every time, the first thing we do is call clearRect 0, 0, that's the top left, and the full width and full height of the canvas. So now it clears all of it, and then it draws a new rectangle. It clears all of it, draws a new rectangle, clears all of it, draws a new rectangle. Okay, that, you don't really need to worry about that. That's just how we're getting stuff on the screen. But let's start off with a rectangle class. So we've created a whole new file. It's good practice to have a whole new file for every class. So we're going to have a class called rectangle. We want a property of x to be 0. We want y to be 0. We want width to be 100 and height also to be 100. So now we could say rect equals new rectangle. We need to rectangle, we need to load it up. So now we're going to draw rect.x, rect.y, rect.width, and rect.height. So that actually, let's give it a color as well. Color is yellow. The company I currently work for, their name used to be Yellow without a W, and so every time I write yellow, the color with a W, I write it yellow without a W, and then like separately have to sort of remember that I need a W, which is what you maybe didn't notice, but is what I did just there. It sort of messes with my head. Okay, so we're no longer updating X and Y values that are just stored locally. Let's see what happens. We've got a rectangle on the screen, so that's good. We can do 2, rect 2. We can do the same thing here. Rect 2, rect 2, rect 2, rect 2, rect 2. Are there 2 on the screen? We don't know. So now we want somehow to change a value on, let's say, rect 2. Rect2.x is 200, rect2.y is 300. So we've got 2 different instances of rectangles. They each have their own data inside them with these properties. They have their own X and Y, they have their own width and height, and they have their own color. This is not a great way to kind of set up our rectangles. What we want to use is this, we want to pass arguments to rectangle. In JavaScript, a class is actually just a function. And that's not really true these days, but historically, kind of older versions of JavaScript, it is actually just a function. So, with these brackets, what we want to be able to do is pass it the x and y coordinates of these particular rectangles. So what we want is some way, and in fact it's kind of telling us here, what we want is some way to get access to these two arguments that we're passing through to this sort of function rectangle. This, I mean, never really thought about those bits and what each of them means, but this word constructor, so that is referring to a function that gets called when a new object is created. So we're creating a new rectangle, and inside the rectangle a function actually does get called that is called the constructor. So inside here, console log in the rectangle. So it's logged out twice in the rectangle. We can have a look at what this is in the rectangle. X0, Y0, they look the same, but they are actually two different objects. If we set rect2.x, now this is confusing because right now it still says x0, but if we click it again, it says x100. So I think I might have shown you this before. It is this little thing says value below was evaluated just now. So like every time we click to open the object, your browser has a look at these values again to give you the most up-to-date version. The point at which this was logged out, these values were actually x and y. These values were actually 0. Only down here does it get set to 100. So that's why it's 0 here, but actually if we look at it, it is now 100. But we are accepting x and y values in the arguments of the constructor. So let's log those out in the rectangle. Here's the rectangle, and then those x and y values. Here we've got 0, 0, 200, 300. So now this dot x equals x, this dot y equals y, and yeah, it's still kind of logging out, but if we set them before we call it, now we can see that as soon as we get past this line, the x and y values of rect2 are 200 and 300. So we've got two instances of the same class, and they both have their own attributes. We could pass a width and height through here, we could pass a color if we wanted to specify colors for all of them, but for now let's just leave them as yellow, 100, 100. And let's do this slightly differently. We're going to have an array of rectangles. So now in our draw function we can say rects.forEach for each rectangle, and we just draw each rectangle in our rects array. So if we do want another one, maybe there's some sort of button click and we push one in, as soon as we push a new one in, this is going to respond and we're going to get a new rectangle in there. In fact, because everything's global, I can do that. Rex.push new rectangle. Don't really know where that's going to be, but okay, it's down here. So a third rectangle has just been pushed into the rectangles array, and it's got its own data, its own constructor, it's logging out. Okay. So now we could suppose we could have a what can we do? What's going to be kind of fun and also demonstrating that stuff. Oh yeah, one thing I want to do. I don't actually want this inside my draw function. These two lines could very easily turn into sort of several lines by specifying a stroke around the shape, a shadow, or a particular image or something. So in fact, we're going to have a function, and now I'll talk about functions and methods. There are two ways to define them in JavaScript. This way is actually defining an instance method, and this is defining just a property, just like one of these, where the value is an arrow function. Now, what's the difference? So let's draw arrow, draw arrow this, and draw this. So remember earlier I said this is actually really confusing in JavaScript. So we're going to say for each rect.draw and rect.draw arrow. I've realised that's not actually going to demonstrate it. So we're getting loads and loads of logs. It actually is always the same rectangle, so draw 0, 0, draw arrow 0, 0. I'm not sure why they've disappeared. Why have they stopped showing up? Oh, because, right, I removed the canvas context stuff. So this, I suppose, is slightly weird, but set timeout. So sometimes you can pass a function as an argument if you're going to use a callback. So instead of having an anonymous function, an arrow function that just calls some other function, we can just pass a reference to the function. So draw arrow, draw arrow. So now we have draw, and remember we're logging out this. This inside draw is actually the window. The window being like, I don't know, window.add event listener, whatever. It's the browser. Whereas draw arrow is the rectangle. Like, to me, this, because I'm in this class, this should just always refer to the instance of rectangle. But because JavaScript is weird, depending on how this function is actually called, so notice that we aren't calling this function, we're telling the window to call the function draw in 0 milliseconds. So we aren't actually calling it, it's the window that's calling it. And when you have a method, it the context of this changes based on how it was called. Basically, it's confusing, and just forget about the fact that you can write functions in that way. The only time you're going to write functions like that, or methods like that, is the constructor. Every other time you want a function, you're going to create it as a property set to an arrow function. So rect.draw arrow. Then inside here, actually here, we're going to pass the context. We receive that context. And in here, we're deciding that context dot fill style is this dot color. Context dot fill rect is this dot x, this dot y, this dot height, no width, this dot height. So now we're going to have a bunch of rectangles, we're going to have a bunch of circles, we're going to have, oh that should not be draw arrow, we're going to have all sorts of different things in our scene, in our game, and they're all going to have their own way to draw themselves. And in this draw function, we just iterate over all of our objects and call draw on them, because they all should decide within themselves how they get drawn, not outside here in the main game loop. Okay, where are we? Cool, so we're back here. Now, let's do something like rect.move. We're going to have a function in here, this dot x plus plus this dot y plus plus maybe we add a new class called fastRect, which class fastRect extends the class rectangle. And all it does is it overwrites the move method, the move function that was declared in the rectangle, and it increases it by 2 every time instead. Maybe we have speed is 2, this dot speed just in case, maybe we want to change it later on. And here we can have fastRect. So now we've got some polymorphism. We've got an array of rectangles. We are including a fastRect in there because actually it is just a rectangle. So we're calling this down here and we're able to call draw on it because it's just a rectangle. We want to load it up, fastRect. After rectangle, this is kind of important when we're loading up files like this. And now we have one rectangle that moves twice as fast as the others. So we've done some inheritance, we've done plenty of encapsulation and abstraction, and we've got some polymorphism in there as well. Okay, 17 past 7. Now we just want to build a game that's kind of fun. So let's have our rectangles be a bit smaller, and instead of fast rect, we're going to have an enemy. The color is going to be red, speed is going to be 2, enemy, and we'll figure something out there later on. So enemies, for each enemy we draw it, for each enemies we move it, for each enemy, and we probably don't want these rectangles at all anymore. Okay, and here let's have enemy. Okay, so it's now red. It's extending rectangle. It is just a rectangle with a speed of 2, and it's red. So let's do the same for player. The player is going to be a rectangle. It's going to be a blue rectangle. And we're only going to move it if the keys are down. So exactly how we do this, there's a million different ways to do it, but to demonstrate another of the things we talked about with inheritance, I'm going to have my constructor. I'm still going to take x and y just like in the old school constructor, in the kind of parent constructor. But to apply, we could say this x and this y. We could do that if we wanted. But what if we decide something else in here we want to add, and then we've got to add it into player. So remember how we had parent.live or something like that in the slides. Actually, we have another keyword called super. So in lots of languages, the class that this class inherits from, or in JavaScript extends, is known as the superclass. So the rectangle is the superclass in this case, and where down here we might say super.move, because it's in the constructor, we just say super, and we pass it those x and y values. Maybe, in fact, the player, when we create an instance of player, it doesn't receive x and y values. Maybe the player always starts at 250, 250. And so that way we've encapsulated that decision making inside the player class and not outside in the index. We always start the player as a rectangle at 250, 250. What am I doing? Oh, controls. Okay. So we can have document add event listener key down. We can have, we take the event in here, console log event.key. Oh, I need to create a player. So const player is new player, and okay, that'll do. Player is not defined. So we're not rendering it. So let's chuck it into here, player.draw. Can I set property fill style of undefined context? Okay, so our player is being drawn in the middle of the screen. I'm pressing the arrow keys, and inside player we're logging out event.key. So if event.key is arrow left, we're gonna change these to X speed, or let's do speed, and let's do direction is going to be an object with X and Y. If event key is arrow left, we want to set this dot direction dot X to minus this dot speed. We do the same for right, up and down. We change X to positive speed. If it's up, we change it to Y to negative speed, and if it's down, we change Y to positive speed. So now move this direction. Actually, we want it to be direction dot X and direction dot Y. Player.move. It's not moving anywhere. And I can sort of, not very well, move the player around. We can do the same for key up. If event key arrow left, I mean this is not great, but whatever. Now I can move the player around with a bit more grace. Okay. So we've got the super call of the rectangle constructor to set up the X and Y positions to be 250, 250. We maybe instead of move on the rectangle, we probably don't want move to be on rectangle, because it should, to me, just be a sort of static rectangle that gets drawn at a particular position. So I think the enemy and the player should have their own move functions, and they do. Now what we can do is we can have the enemy move towards the player. How can we do that nicely? So we can pass the player into move, or we could say move towards player.x and player.y. So again, we're being abstract and descriptive. Maybe we have a separate function called move towards, which takes a sort of target X and target Y. Let's probably chuck direction in here, and in fact player and enemy are looking fairly similar, so I think they should be their own class that extends rectangle, but we'll do that with some refactoring later. So target X, if this dot X is less than target X, this dot direction dot X equals this dot speed. If this dot X is greater than, direction is going to be negative, and Y, and we've got Y target Y. I mean, I could very well be wrong with that, but let's see what happens. Yeah, not so much. Move towards, and that needs to call this dot move. Oh yeah, we haven't really. Oh yeah, I suppose we're accessing properties of this, but we haven't called any other functions within a class. So move towards is the only thing that we call inside index, but actually that calls move as well. Oh, I'm dead. That's moving far too quickly. It's not a very good game, but now when we have a enemy constructor, we actually don't want I don't know, maybe let's keep the constructor out of the enemy. What we're going to do is have some kind of set interval that's going to call every 1.5 seconds, and enemies.push, we're going to push in a new enemy with math.random times canvas.width. And just for fun, let's do that first one as well. Oh dear. So obviously you don't really die, you don't really lose, it's not very good, there's no way to kill them, but we have loads of different instances of enemy. They all have their own data, they all inherit from rectangle, so does the player, even though they then have their own specific behaviors. And this is a not very good example, but hopefully it's kind of an example of why games are really well suited to object-oriented programming. So if you can imagine applying this to kind of what you've been doing so far, you'd have a sort of login button as the class, and that might be helpful, but the way you've been building your websites so far, I don't really like building websites like that using object-oriented code. Next module, where you learn React, React does, or kind of can, React used to be very object-oriented. They've since changed to be much more, kind of less object-oriented and more functions, but it's a really, really important paradigm to use, because tons of other languages are like exclusively object-oriented, and you really do need some sort of exposure to object-oriented code, even if JavaScript isn't quite set up for using object-oriented paradigms. Okay. So 732. What else can we add to this to make it more fun? Also, while you're thinking about that, I'm just going to go and stir my beef stew, which is not a euphemism. We're fine, nothing's burnt, we're okay. Okay, did anyone spend that time? Have to leave here, mushtaq's off. Okay, great. Anyone have any fun ideas of what we can do with this little game?
Nope.
Okay, so I'm gonna have to think of something then. So we're adding a bunch of enemies. We could add. Oh yeah, I said I'd refactor into another class because enemy, color, speed, direction, player, color, speed, direction. They look pretty similar, and then they have a move, which is actually just this X direction, this X direction, this Y direction. I'm going to refactor into an entity class. An entity, I don't know, it's basically like anything in a game, which is a bit silly, but it will do for now. So this is going to extend rectangle. We're going to have color and speed. They can be specific to the enemy and the player, but move and direction are going to be additions to the rectangle class. So enemy is just that now. Player doesn't have that. Direction, it doesn't need that. Player is going to have the higher speed. Yeah, higher speed. And then these need to inherit from entity. So we're now sort of two levels of inheritance deep. So to our users, it doesn't look any different, but now we have much neater code if we want to decide that actually this is going to be based on some sort of velocity or whatever. We want to apply some gravity to it, then we can. Guessing we don't want to do that because that'd be a bit mental. All right, what can we do? Let's have a little pickup. Let's have every time the player picks up a thing, it goes a little bit faster. Maybe the enemies could do the same. I don't know. So we're gonna power up. So we're going to go all the way back. We're not going to inherit from rectangle because this is going to be a circle. Power up can be pink. Radius can be 5. X and Y, constructor X and Y. Fill style, fill circle. Have I just made that up? This radius fill circle. Doesn't really look like it. context. So I'm going to have to look up here. Fill circle. Okay, how to write your own function like fill circle? Well, okay, begin path arc. Oh my goodness. Yeah, I'm just going to nick theirs. Okay, so we call fill circle that function, we pass it the context object, and we give it an x, a y, and a radius. So other libraries and languages have something like fill circle, and the first argument is x, next is y, next is radius, which is why I kind of guessed correctly. But obviously the built-in canvas has no direct way to draw a circle, but it does have a way to draw an arc. So this is now saying at this x and y position, at this radius, starting at angle 0 and going to angle 2 pi, because it's radians, so that's a full circle, draw an arc and then fill it in with the current fill style. So it's a bit weird, but this is kind of nice. So we've got power up, and in index again, set interval, we can have to 500, and in fact, instead of enemies and player, oh no, they've got different things. Okay, whatever. I was going to say that they can be in their own, just one array of entities, but never mind. Player, we're going to have an array of power-ups. So power-ups dot push new power-up. Again, random positions. So power-ups dot power-up. Right now we're not updating it at all, so we don't really need it in update. And then power-ups, then will that do? Will that be enough? X, Y, pink, yeah, that will probably do something. There we go, there's a power-up, there's another one, there's another one. Okay, so now we can, on our player, we can check if it's close to any of the power-ups, and if so, like increase the speed by 1. So let's do something like that. Check for power-up collision. Oh, one thing you might have remembered from the pseudocode, but is missing from here, is the private keyword or the public keyword. So that says the private modifier can only be used in Typescript files. The concept of private and public is really important in object-oriented programming, but because JavaScript is not strictly an object-oriented programming language, it doesn't actually have this idea of private and public functions, and that's what we're going to look at on Thursday. TypeScript is just JavaScript, but with some added functionality. So we're going to look at that on Thursday. So we're going to have an array of power-ups for each power-up, which is going to be an instance of this power-up. We've got x, y, radius. We can have something like if this dot x minus power-up dot x, that makes it always positive, is less than power-up dot radius, or same thing for y. This is a pretty hacky way to do it, but never mind. Y. Then let's just log something out for now. Power up eaten. Come on, give me a power up. Oh dear. I mean, I just want to avoid them, like, even though nothing actually happens, you just want to avoid them. Okay, we're not calling that player.check for power up collisions. We pass it the full array of power up so it can check them all. Power up eaten, it works. Okay. Oh yeah. What? Yeah. Okay. This needs to be and. So you can see that we are here, and this is counting up. We can. Oh, that doesn't really help, but if we go, I mean, there's too many. If we go down here, it stops. But as soon as we come like on the same, roughly the same x or roughly the same y as any of these, then we are saying that we're eating a power up. So it's and. Okay, so here I would previously have been eating one, whereas here, there it's a bit funky, but the top left is where I draw the rectangle, so it's like this point is in this radius, and actually it's the radius plus the width and height of this. Okay, whatever. That'll do. Power up eaten, this dot speed plus 1, and then here we can do some nice JavaScript stuff. Call back. We can pass the power up back to a callback that we're going to have in here. So we can have some kind of function, destroy power up. We're going to receive that power up. We can pass that as a callback, and it's going to be not very nice, but power up index is power ups.index of. We want to find the index of the power up in the array, and then we want to splice the array. Power ups.splice. What does splice do? Can anyone remember? It removes elements from the array, and great. Starting at power up index, delete count 1, and we don't replace it with any. That should do it. I couldn't remember any of that because I never use splice. I always use filter. If I want to create like an array and remove stuff from the array, I'll always use filter, but that would involve me saying changing this to let. So this is fine. So hopefully it will actually work. So let's go all the way down here. Yeah, he's faster. These enemies are never going to catch me, although they do pretty regularly. And now he's too fast because anyway. Oh dear. I don't think it's even possible for me to get that one. But you get the idea. So a kind of mix of neat JavaScript features, like not every language you can just pass a function through as an argument and use as a callback somewhere else. That's really neat and that's really JavaScript. Combination of that and object-oriented code makes for in my opinion, a really nice kind of environment for building this sort of thing. Okay. AJ's off as well. Jeez. Daniel and Dahe, do you have any questions, ideas, or do you just want to leave?
I want to see. Yeah, to the end. To be honest, I need a recap as well, if you have time.
Okay, so
Yeah, it's going to be a long recap.
Let's go up to the sort of top of the player. So first we have a class called rectangle. Each rectangle that gets created is going to have these available properties and these default values. When a new rectangle gets created, this constructor function gets called. We can pass in some argument, so here it's telling us we call rectangle, we pass in x and we pass in y. We are therefore setting the x and y values stored inside each individual rectangle to whatever we pass through to the constructor when we create a new rectangle. We also have a function defined on each rectangle, takes the context and draws stuff to the canvas using the attributes, the current attributes of that individual rectangle. Next level up, we go to an entity. So not all rectangles need to move. So the rectangle doesn't really need to do anything with like speed or direction or have the move function. It just needs to draw a rectangle. The entity is just a moving rectangle. So we extend the class of rectangle, we add the function move, and we add a property of direction. So move is now going to update the x and y values that are stored down in rectangle with the current direction x and direction y values. So entities are moving rectangles. Then a player is an entity. A player extends the class entity because it's a moving rectangle. It overwrites the color that is all the way down in rectangle. Rectangles have by default the color yellow, but a player overwrites that and sets the color to blue. It also adds a property of speed. Inside the constructor of the player, we call super. We call super, in fact, as it shows us here, on the entity class. Entity doesn't define a constructor, so it then goes to the superclass of the entity and comes through to this constructor. So this constructor is calling super, which calls this constructor, sets the x and y to 250, 250, and then it sets up the document add event list and those for the keys, the key presses, but we don't need to worry about those.
Alright, so because the player extends entity and entity extends the rectangle,
Yeah.
it's able to get this to make the super on that constructor in the rectangle.
Exactly. So if I don't quite know what we'd want to do in entity, but if we want to do something else in entity, we'd also probably want to call super x and y in there and console log in entity constructor. And now creating a player does specifically call the entity constructor because we've overwritten the constructor in rectangle, but actually it then just calls super and calls the constructor in rectangle, but also does its own stuff. So we can have this like chain of calls through to kind of ancestral classes. So that's rectangle entity player. Then inside index, where we are creating a player, we don't pass any arguments because the constructor has been defined without any arguments. We're hard coding the middle of the screen. So to create a new player, we don't pass any arguments. And now this player object we can call move, which is in fact specified in open to the side. Move, player.move, which is not in player, but it is available in player because it extends the entity class, which defines move. We're calling player.check for power up collision, which is not in entity, it's not in rectangle, it's defined on only the player. So enemies don't know anything about checking for power-ups, entities don't, rectangles don't. Only the player needs to know about checking for power-ups. We've got that same idea with each enemy. Each enemy has a function called move towards, which updates its current direction and then calls this.move, which isn't defined on entity but on enemy, but is defined on entity. So this.move actually has all of these things. It inherits from rectangle, so it has everything that's defined in rectangle and so on. So everything inside entity is actually inside enemy, everything inside rectangle is inside entity, and therefore inside enemy. Power up, that's just its own class. So we've got a constructor, we've got these properties, we've got a function called draw in our index. We're calling draw on all of those different things in our games. And yeah, so that's sort of covering all of those object-oriented principles, really. What else? Was there any part in particular you wanted me to go over, or just all of it? Like,
No, that was perfect to be honest.
Okay.
Yeah, I just needed to. Sometimes when we get jumbled, so when we go over it again, like the extending stuff, and so extending essentially allows you to not have to have the same code in various places.
Exactly.
So it keeps everything streamlined.
That's exactly it. So that's an example of that was this entity class. So the enemy and the entity were both, the enemy and the player were both extending the rectangle class, but they both had these identical properties and functions in there. So I decided actually I'm going to have kind of intermediate one called entity that the player and the enemy both inherit from. So that's why we do it, because what if we want to change how they move, or change, we make it 3D and we need Z, and so that is kind of, what does that adhere to? Sort of abstraction, sort of encapsulation, sort of polymorphism, and definitely inheritance. Yeah. So all of those principles, you're applying them and thinking about them all the time, which is kind of why I said you don't really need to remember them specifically, but when you are building a class that feels really, really similar to another class, you should just think, is there any way I can take this out? I can have another class that it can inherit from, just to make your life easier, just to make things readable later on.
Yeah, that makes a lot of sense. I'm not sure if Delphi wants to say anything. Really well.
Okay, cool. Well, 7:58, let's call it a day. Thanks very much. Object-oriented code is really, really important. It's one of those things that, as a sort of front end